Hello student, let us see what is optimization algorithms. In deep learning we have the concept of loss. Loss, it is nothing but error between the calculated value and the targeted value. By using this loss function we are trying to train our neural network such that it will perform better. So when it will perform better, if this loss or error it is minimum, so essentially what we need to do is to take the loss and try to minimize it, because if it is minimized, if the error it is less, then we can say our model it is performing better. So this process of minimizing that loss, maximizing, obviously we are not going to maximize it. This is the process of optimization, and in neural network our aim is to minimize the loss, and this is called as the process of optimization. In this case we need to take care of two things. One is what loss function we are selecting, and second is which optimization algorithm we are using. For loss function we know that these are the different kind of loss function: mean absolute error, mean squared error, root mean squared error, and cross entropy error. We have already seen by observing what kind of data is, whether it is having number of outliers. So according to the data type we are selecting this loss function. Our main target is to understand what is optimization algorithms. So in optimization algorithms we are having two kinds of algorithm. One is first order optimization algorithm, and second is second order optimization algorithm. When in optimization process we are using first order derivative, it is called as first order optimization algorithm, and when second order derivative it is used, then it is called as second order optimization algorithm. Most of the time first order optimization algorithms are used. These are some of the major optimizers used, like gradient descent, stochastic gradient descent, mini batch stochastic gradient descent, SGD with momentum, adaptive gradient, ADA delta, RMS prop, ADA. Some of them are very important for us. Let us talk about the gradient descent first. Before going to the gradient descent, try to understand some of the terminologies which we are going to use. Epoch, the number of times the algorithm runs to the whole training data set is called as epoch. Imagine if you are having total 100 observation in the given data, that is 100 rows in your Excel. So when it will complete that turns of all 100 observation, it is called as one epoch. Sample, a single row of data set, that is a single observation, is called as sample. Batch, in 100 observation if you are selecting a number of samples like 10 samples, it is called as the batch. Learning rate, it is a parameter that provides the model a scale of how much model weight should be updated. We are updating that weights, so how much it should be updated. That rate, it is nothing but the learning rate. Generally we are denoting it by alpha, and it is having a range from 0 to 1. Cost function, loss function, again this is known concept for us. Cost function, loss function, error, whatever we are calculating in calculated output and targeted output. So when we are applying any algorithm, there are some stopping criteria. What are the stopping criteria? The loss improvement in one epoch is less than the set value. Actually some of the parameters we are setting while we are training the neural network. So we are setting some loss improvement value also. If it is less than the set value, or loss has been minimized to a goal value. If we want that loss function, it should be 0.01, and if we reach to this value, then we will stop. A maximum number of epoch is reached, like 1000 epoch even though completed, we are not getting the required loss, then this may be the one of the stopping criteria. The maximum amount of computing time has been exceeded. The error on the selected subset increase several epoch. So these are some of the top stopping criteria. Now let us try to understand what is the gradient descent. See, as we know, if we are considering a function of x, to minimize the function, we always try dou f by dou x it is equals to 0. So as initially we have seen, optimization it is nothing but minimizing or maximizing a function. And what is our main aim? Minimize error. Error compared calculated value and the targeted value. So E is the function which we are going to minimize. So what will be the process? We are trying to reach dou E by this E, it depends on W as well as bias. So our target is to get dou E by dou W it is equals to 0. Now see this graphical representation. On this side we are considering our cost function derivative, that is gradient del E by del W, and on this side you are considering the values of weights. So while solving the problems, as we have observed, sometimes weight it is increased or weight it is decreased. So maybe this will comes from this side or this will comes from this side. So weight sometimes it is increasing or weight sometimes it is decreasing. And what is our aim? We are starting with this initial weights. Imagine your initial weight it is at this position. So del E by del W, that is value of this. So corresponding value of del E by del W it is equals to, it is here, and our aim is to minimize it, means we want the value for del E by del W it is equals to 0. So now we are minimizing the value of W in each iteration. As we have observed, when you are applying any learning rule, weights are updated, that is weights are minimized, or weights either they are increased or decreased. So here this is decreased, either it is increased or decreased to get the value for del E by del W is equals to 0. See all the factors here: gradient, del E by del W, initial weight, increment step. So increment step, if you are observing, these arrows are showing you the increment rate. So this will decide what should be the learning rate. And minimum cost, here you will get the minimum cost. Derivative of cost, that is nothing but del E by del W. Okay, so let me explain you this figure. Initially our weight was here. Just imagine if it was 2 point something. Now when you are applying complete process of feed forward, you are calculating something, you are getting an error and applying the process of back propagation to update the weights. This is updated in first iteration up to this point, in second iteration, in third iteration, in fourth iteration, and in fifth iteration. So slowly we are reaching to 0. Once we will reach here, the error becomes minimized. Maybe every time it is not equals to 0, but we are reaching it to 0 so that optimize del E by del W, optimize, and it will gives you that a model performing very well, that is where the error it is minimum. Now let us see how this process will happen. So what kind of process algorithms you are applying for each iteration, one by one we will see. We will start with gradient descent or batch gradient descent. So in this, first of all start with what is the formula we are using. This is the formula we are using. W nu is equals to W old minus alpha del E by del W I. So the same formula we are using for delta learning for back propagation. What are the advantages? Easy to compute, easy to implement, easy to understand, because simply you are applying a formula. May trap at local minimum. Weights are changed after calculating gradient on the whole data set. So if the data set is too large, then this may take years to converge to the minimum. Requires large memory to calculate gradient on the whole data set. I hope from all this point you understood that gradient descent or batch gradient descent, it is applied for whole data set. If you are having total 100 observation, 1 2 3 and so on up to 100, so all for this 100 observation you are calculating the error like E1, E2 and so on up to E100. So this 100 errors are calculated, and final error, it is nothing but average of all the errors, E1 and so on up to E100. So applying this process, it's obviously taking time, even though it is more accurate, but it is taking too much time, as well as it is taking memory also. Example, like there are total 5 observation. For all 5 observation we are considering the error, and we will consider average of the error, and after that only you are updating the weight. Until and unless calculated all the errors, we are not updating the weights, and that's why the process is little bit okay. Then the next point, it is stochastic gradient descent. So in stochastic gradient descent, let me explain you with this figure. Again, 5 only this observations we are considering. In this, what happens, you are calculating the error for each observation. So for each observation, if you are calculating it, it will take less time, but in this case there are lot of variations in the calculated error, and that's why whatever the figure you are getting, like if we are observing this, in previous case slowly you are approaching to 0. Okay, on any side if you consider, slowly you are approaching to 0. Now in stochastic gradient, what happens, for each observation you are calculating the error. So such variations you are observing, it is not a smooth graphical representation. See the advantages, memory requirement is less compared to the GD algorithm, as the derivative is computed taking only 1 point at once. Disadvantages, the time required to complete one epoch is large compared to the GD algorithm, because see, one epoch in previous case, in batch gradient descent, you are considering error update, weight updation after completing one epoch, but here you are updating the weights for each observation. So to complete the one epoch, it will take time, takes long time to converge, as graph it is not smooth. So reaching up to this point, it will take too much time, may stuck at local minima, so sometimes it will stuck also. So mini batch stochastic gradient descent is trying to merge benefits of both previous descent algorithms. Mini batch gradient descent, if you see, let me again explain this with graphical representation. In mini batch gradient, what we are doing, okay, let me show you this. We are considering batches. So batches means if there are total 5 observation, randomly we are considering the batches like this and this. A set of 2 observation you are considering, then this and this, set of 2 batches you are considering, and according to the batches you are updating the weights. So it will take less time comparatively, as well as the graphical representation, whatever, maybe it is not smooth as batch wise gradient descent, but definitely as compared to the stochastic gradient descent, it is little bit smooth. By mistake I am considering the same slide actually, but I hope you can understand. In stochastic, you are considering each observation for error updation, for weight updation, but in mini batch you are considering a small batch randomly. Let me compare. What are the advantage and disadvantage? Less time complexity to converge compared to the HGD. Disadvantages: the update of MB HGD mini batch HGD is noisy compared to the update to the GD algorithm. Gradient or batch wise, obviously it is having little bit noise as compared to the batch wise. Take a longer time to converge than GD algorithm. See, batch wise, let me compare this. We are having three: batch wise gradient, stochastic gradient, and mini batch. Here you are considering entire dataset for updation. In stochastic, single observation, and in mini batch you are considering subset for updations. Data wise, this is the difference. Cost function reduced smoothly. A smooth graph you will get here. Lot of variations you will observe in stochastic, and as compared to this two, it is better than the stochastic, but obviously as compared to the batch gradient descent, still it is having some noise. Computation cost, it is very high because in each updation you are compulsory considering whole data set. Computation time, it is more as compared to this. Computation time is lesser than HGD. Computation cost is lesser than batch gradient descent. Here you are considering whole data set, but as compared to this you are considering batches, so obviously the computation cost, it is lesser than the batch gradient descent. Okay, so this is for majorly used gradient descent, that is batch gradient, stochastic, and mini batch. There are some other gradient descent are also used. Adaptive gradient descent, you can see this is different than all other gradient descent because every time it is changing the learning rate. The change in the learning rate actually depends on the difference in the parameter during training. Parameters are nothing but weights and bias actually. The more the parameter get changed, the more minor the learning rate range. So as you have seen 0 to 1, this is the range of alpha. So this range, it is changing continuously, like in each iteration if the weights are not increasing that much, so accordingly the learning rate will be increased. Similarly there are others one also: AdaGrad, Adam, RMSProp, deep learning optimizers, AdaDelta. So these are some of other optimizers which are used for training the algorithm. So majorly we will concentrate on batch wise gradient descent, stochastic gradient descent, and mini batch gradient descent.